Chapter 1: The Impossible Weight. They didn't have cranes. They didn't have engines. They didn't have steel cables, forklifts, or diesel-powered winches. Yet somehow, thousands of years ago, civilizations across the globe moved stones weighing not just a few tons, but over 1,000 tons each. Stones so heavy, so massive, that even today, our most advanced cranes would tremble under the strain. The question is how? And perhaps even more unsettling, why? These are the trilithon stones, each weighing an estimated 1,000 to 1,200 tons. They have sat here in the ruins of Baalbek for thousands of years, defying explanation. Mainstream archaeology says they were quarried nearby, shaped with bronze tools, and dragged into place by sheer human effort. But when you stand before them, towering like sleeping giants, you can't help but ask, really? Bronze tools? Ropes and logs? Or was there something more, something we've forgotten? Just a short distance away lies another monolith, the stone of the pregnant woman. It is even larger than the trilithon stones, weighing an estimated 1,200 tons. It's carved, it's shaped, it's ready to move, but it never left the quarry. Why? Did the builders run out of time? Or was this their final attempt before losing the technology that allowed them to move the others? Baalbek is not alone. Across the planet, ancient engineers left behind silent monuments, testaments to a mastery of stonework and movement that still challenges us today. In Egypt, the granite blocks of the Great Pyramid weigh up to 80 tons each. In Peru, some stones at Sacsayhuaman tip the scales at over 100 tons, their edges so perfectly interlocked that not even a razor blade can fit between them. And at Stonehenge, the blue stones were transported from over 150 miles away. But here's the problem. Our modern cranes have weight limits. Our trucks have load restrictions. Our roads need to be reinforced to carry oversized cargo. Even with today's technology, moving 1,000-ton stones without damage is nearly impossible. So how did ancient people, without engines, hydraulics, or even the wheel in some cases, pull off these feats? The standard answer is manpower. Thousands of laborers pulling with ropes, rolling stones over logs, or dragging them over grease sledges. But here's the catch. The ground itself would collapse under that kind of weight. The logs would shatter. The ropes, made from plant fibers, would snap long before the stone moved an inch. So maybe, just maybe, we've been looking at this the wrong way. Maybe the people who moved these stones weren't as primitive as we assume. Maybe they had techniques or technologies that we don't understand today. And maybe that knowledge didn't vanish by accident. Some researchers propose ramps miles long. Others suggest rolling the stones inside giant wooden wheels. Still others go further, imagining advanced methods such as magnetic levitation, anti-gravity, or acoustic resonance, where sound waves lift and move stone. These ideas often get dismissed as pseudoscience, but here's the uncomfortable truth. No one has successfully replicated the moving of a 1,000-ton stone using only the tools and materials available to ancient civilizations. If these stones could talk, they might tell us of a lost chapter in human history, a time when engineering was as much about intuition as calculation, as much about the mind as the muscle. A time when moving 1,000 tons wasn't impossible. It was simply part of the plan. Over the next chapters, we're going to investigate the most compelling sites, the most daring theories, and the most baffling evidence. From the mountains of Peru to the deserts of Egypt, from the ruins of Lebanon to forgotten quarries in India, we will follow the clues left behind by ancient engineers. And by the end, you might find yourself asking not just how they move these stones, but whether we've underestimated the civilizations that came before us. Chapter 2: The Impossible Stones of Antiquity. Imagine standing before a wall, not just of stone, but of impossibly huge stones. Each one the size of a train car. Each one weighing more than 1,000 tons. That's 2 million pounds of solid rock. No cranes. No bulldozers. No modern steel cables. Just people. And yet, thousands of years ago, someone or something moved them in a place with eerie precision. And here's where it gets even stranger. The stones are so perfectly aligned that even today, engineers admit they'd struggle to match this feat, the smallest gap between them, barely enough for a sheet of paper to slide through. No mortar, no cement, just flawless stonework. The ancient site of Baalbek in modern-day Lebanon is home to these mind-bending megaliths, known collectively as the trilithon. Archaeologists say some of the stones were quarried, shaped, and moved from a site nearly a kilometer away. And we're not talking about a gentle downhill roll. We're talking uneven ground, slopes, and the sheer force it would take to budge something heavier than 150 elephants. So how did they do it? The official answer, if we can call it that, ranges from logs and manpower to sledges and ramps. But here's the problem. The sheer weight of the stone would crush logs instantly. The friction would be enormous, and you'd need a workforce larger than the population of the surrounding region at the time. Some researchers believe the ancients knew something we've forgotten, some lost engineering principle or physics trick that allowed them to defy what we think is possible. Was it a clever use of counterweights? Did they use water to float the stones part of the way? Or, here's where it gets really wild. Did they master some form of vibration technology to reduce weight temporarily? If that last one sounds crazy, wait until you hear this. Across the world, in the high Andes of Peru, stands another puzzle, Sacsayhuaman. This fortress is made of enormous polygonal stones, some weighing more than 200 tons. They don't just sit neatly together. They interlock like a jigsaw puzzle, with angles and curves so precise it's as if the stones melted into place. Local legends tell of the stones being sung into position, literally moved by sound. While mainstream historians dismiss this as folklore, modern experiments have shown that sound waves at certain frequencies can indeed cause objects to levitate or shift. Could the ancients have known about acoustic resonance centuries before physics textbooks existed? Let's circle back to Baalbek. Picture it. Thousands of years ago, before Rome, before Greece, before our history books even begin. The land is quiet. In the distance, you hear the rhythmic chant of workers, the creak of wooden structures, maybe the rumble of something heavy being drawn across the earth. And then a stone the size of a house glides forward, inch by inch, as if gravity has loosened its grip. This isn't just idle speculation. In 2014, archaeologists discovered an even larger stone still in Baalbek's quarry, the Stone of the Pregnant Woman. It weighs an estimated 1,650 tons. That's the weight of 4 Boeing 747 jets. And it's been sitting there for thousands of years abandoned. Why? Was it simply too heavy to move, even for the mysterious engineers who built the trilithium? Or did something happen? Did they lose the technology or the knowledge suddenly? Here's a sobering fact. The largest modern cranes in the world can handle loads in the same weight range, but only under ideal conditions, with precision-engineered equipment. Yet the builders of Baalbek worked with primitive tools, no reinforced steel, and, according to our history books, no advanced machinery. So, either A, our ancestors were far more ingenious than we give them credit for, or B, our history is missing a critical chapter. What if the ancients didn't just rely on brute force? What if they understood the natural world in ways we can barely imagine today, harnessing water pressure, solar heat, or even Earth's magnetic field to aid them? Some fringe researchers go even further, suggesting that these massive projects weren't purely human efforts at all. The precision, the scale, the seeming disregard for logistical limits, it's enough to make you wonder. Were they alone? But before we drift too far into speculation, let's remember, mystery isn't proof. Still, there's no denying the pattern. Baalbek, Sacsayhuaman, Stonehenge, the Great Pyramids. Across continents, across cultures, humanity's earliest monumental structures seem to share one thing in common. They all push the limits of what's supposed to be possible. In the next chapter, we'll look at another ancient site where stones heavier than 1,000 tons were not just moved, but stacked with an accuracy that would challenge any modern construction team. And here's the twist. No one can agree on who built it or why. Think about this. The average modern crane you see at a construction site can lift about 20 to 60 tons. A specialized heavy-duty crane might push up to 1,000 tons, but those require massive counterweights, heavy-duty steel cables, precision hydraulics, and a team of engineers. Yet thousands of years ago, ancient civilizations moved stones of equal or greater weight without any of those things. And in some cases, we don't even know exactly how. Take Baalbek in Lebanon, for example. This archaeological site holds one of the largest known stones ever cut by human hands, the Stone of the Pregnant Woman. It weighs an estimated 1,050 tons. That's more than 8 blue whales. But here's the kicker. This stone wasn't just lying on the ground waiting to be admired. It was intended to be lifted and placed precisely into a temple wall. The ancient builders cut it from solid bedrock with such clean precision that even modern stonemasons are baffled. And Baalbek isn't alone. One in Egypt, the obelisks carved from a single piece of granite, some weighing over 300 tons, were dragged miles from the quarries of Aswan to stand upright in temple courtyards. Two in Peru, the fortress of Sacsayhuaman is made up of massive limestone blocks, so tightly fitted that you can't slide a razor blade between them. Some of these stones weigh over 100 tons. 3 in India, the unfinished monoliths of Mahabalipuram reveal the raw scale of ancient stone-cutting ambition. Now here's where it gets even more puzzling. No ancient texts have been found giving a detailed step-by-step manual on how these feats were achieved. In many cases, there's no evidence of wheels, cranes, or even advanced metal tools that could handle this kind of weight. Some theories say they used 1 ramps and rollers made of logs, 2 counterweight systems using sand, water, or clay. 3 massive teams of workers pulling with ropes. But when you run the numbers, something doesn't add up. To move a 1,000-ton stone on wooden rollers without breaking them, you'd need logs as thick as tree trunks and roads strong enough to bear that weight, something that in many sites didn't exist. Then there's the precision problem. Many of these stones weren't just moved. They were aligned with extreme accuracy to fit into walls, temples, and monuments that still stand today. That means the builders not only had to move them, but also lift and position them without cranes or forklifts. It's almost as if they knew something we don't, a lost technique, a forgotten technology, or a method that was so common back then that nobody bothered to write it down. And here's the thought that keeps historians awake at night. If they did have such a method, something that allowed them to move hundreds or even thousands of tons effortlessly, what happened to it? Why did it vanish from human knowledge? And could rediscovering it change the way we build today? In the next chapter, we'll explore 3 leading theories, from pure human muscle power to the possibility of ancient machines and techniques that may have been more advanced than we think. Chapter 3, The Colossi of Memnon, Egypt's Stone Giants. Imagine standing in the golden sands of ancient Egypt over 3,000 years ago. The sun beats down, the Nile glitters in the distance, and looming above you are 2 colossal statues, each soaring over 60 feet high and weighing an estimated 720 tons. These are the Colossi of Memnon, guardians of the mortuary temple of Pharaoh Amenhotep III. Even today, with all our cranes, hydraulic lifts, and specialized transport vehicles, moving such a mass would require a logistical feat of epic proportions. Yet the ancient Egyptians did it without any of those. How? That's the riddle we face. The statues themselves were carved from single blocks of quartzite sandstone, sourced not from the temple's site, but from quarries nearly 400 miles away. Let's pause there for 100 miles. Through desert heat, across the Nile, and into their final resting place. No railways, no trucks, no cranes, just human ingenuity, muscle, and possibly knowledge we still don't fully understand. Historians propose several theories, and each one raises more questions than it answers. The most widely accepted theory involves massive wooden sledges, essentially giant runners, on which the statues were placed. Teams of hundreds, perhaps thousands, of workers would haul the sledges across specially prepared tracks lubricated with water or oil to reduce friction. It sounds plausible until you consider the sheer weight. Even the most generous calculations strain belief. Then there's the Nile factor. Some researchers believe the statues were transported by raft during the annual floods. The stone would be loaded onto a barge, floated downstream, and then hauled ashore. But here's the catch. A 720-ton block would require a vessel of staggering size and stability, one far beyond what we know the Egyptians built at the time, unless, of course, they had techniques that haven't survived in the archaeological record. And here's where the mystery deepens. The ancient builders left behind no detailed blueprints, no engineering manuals. All we have are fragments, inscriptions, relief carvings, and tantalizing hints in temple art. Could it be that this knowledge was considered sacred, passed orally among a select class of master builders, and intentionally kept from the general population? Some fringe theorists go further, suggesting that the Egyptians may have possessed a kind of lost technology, perhaps sound-based levitation or advanced mechanical systems that have vanished from history. Mainstream scholars tend to dismiss such ideas, but the lack of conclusive evidence leaves room for speculation. What we do know is this: standing before the colossi of Memnon today, you feel an almost overwhelming sense of scale. These aren't just statues, they're statements, proclamations of power, permanence, and a mastery of the natural world. Whether through brute force, clever engineering, or techniques we've yet to rediscover, the ancient Egyptians achieved something that still leaves modern engineers shaking their heads. And perhaps that's the real magic of the colossi. They remind us that history's greatest feats weren't always built with steel and engines. Sometimes they were carved in stone, moved by willpower, and immortalized in mystery. In the next chapter, we leave the sands of Egypt and travel to the highlands of South America, where the Inca faced a similar challenge, moving impossibly massive stones high into the mountains without the wheel. Chapter 4: The Forgotten Machines. Imagine this. You are standing in the middle of an ancient quarry, the air thick with dust, the sun beating down on the backs of hundreds of workers. Around you, enormous blocks of stone, some weighing over 1,000 tons, lie waiting to be transported to sites miles away. You might assume these workers are powerless without cranes, modern engines, or steel cables. But what if I told you they might have had machines we've completely forgotten? Ancient texts from various civilizations, Egypt, Mesopotamia, India, often speak in riddles about moving mountains or commanding the stones. Mainstream historians usually dismiss these as poetic exaggerations, but there's a growing body of research suggesting otherwise. Take the Antikythera mechanism, for example, an ancient Greek device found in a shipwreck in 1901. It was a mechanical computer built over 2,000 years ago, capable of predicting astronomical positions with stunning accuracy. The point? If this kind of precision engineering could exist in ancient Greece, why couldn't other advanced machines have existed elsewhere and been lost to time? Archaeologists working in Baalbek, Lebanon, have studied the famous Stone of the Pregnant Woman, a massive block weighing over 1,000 tons. Even today, no crane on Earth could move it in a single piece without breaking it apart. Yet, in the ruins, there's evidence of smooth grooves, possible tracks or rails, and oddly placed stone cuttings that don't make sense for simple manual labor. Some engineers believe these could have been ancient mechanical rollers or counterweight-based lifting systems powered by teams of workers or animals. And then there's the mysterious Roman concrete mixers described by Pliny the Elder. While we think of them for cement, some researchers believe these devices might have been modified to act as giant winches or capstans, capable of slowly dragging enormous stones using a network of ropes and pulleys. The biggest puzzle? The lack of written instruction manuals. But perhaps that's because these machines were considered trade secrets, guarded by elite builders, passed down orally from master to apprentice. When these societies fell, the knowledge fell with them, vanishing into the abyss of history. Even stranger, In certain ancient carvings from Egypt and Mesopotamia, you can spot objects that look like crane arms, winch handles, or gear-like wheels. Are these purely symbolic, or are they literal depictions of tools that have been erased from our collective memory? If these lost machines truly existed, it changes everything we think we know about ancient engineering. And it forces us to ask, what else have we underestimated about our ancestors? In the next chapter, we'll follow the trail of a little-known 19th century engineer who believed he had rediscovered one of these ancient devices and tried to use it himself. Chapter 5. The Physics of the Impossible. The problem of moving stones that weigh hundreds or even thousands of tons has always been framed in the language of impossibility. Modern construction equipment can lift hundreds of tons, but that requires steel cranes, diesel engines, and hydraulic systems that didn't exist in ancient times. Yet, thousands of years ago, civilizations from Egypt to Peru moved stones so massive they still make modern engineers scratch their heads. When we talk about 1,000-ton blocks, we're talking about a single stone weighing the equivalent of 150 African elephants. The Baalbek trilithon in Lebanon, for example, consists of 3 stones, each weighing around 800 tons, and one unfinished stone nearby weighs an unbelievable 1,200 tons. These were quarried and moved without cranes. So how? One theory says rolling on logs. That's the go-to explanation in textbooks. Place the stone on a series of wooden rollers and keep moving logs from the back to the front. But when you actually run the numbers, you hit a problem. A single log would crush under that weight unless it was the size of a massive tree trunk, and even then, friction would be enormous. The logs themselves would have to be hardwoods, and there's little archaeological evidence that enough such wood was available near some of these sites. The second theory, sledges over lubricated surfaces, actually has some surprising evidence. In 2014, researchers studying ancient Egyptian wall art noticed something odd: a man pouring liquid onto the sand in front of a sledge. At first, historians thought it was just water to keep down dust. But experiments show that moist sand reduces friction by up to 50%. Wet sand particles stick together just enough to create a firmer surface, meaning the sledge slides more easily. This could double or triple the load workers could pull. But wet sand only works on, you guessed it, sand. What about sites in mountainous regions? That's where stone ball bearings come in. In 2003, archaeologists in the Netherlands experimented with placing heavy loads on sledges over tracks filled with round stone balls. It created a primitive roller bearing system, reducing friction to a fraction of normal drag. Could the ancients have invented this system thousands of years earlier than we think? Possibly, because tiny spherical stones have been found at the site of Pumapunku in Bolivia, where massive stone blocks were transported and placed with stunning precision. Then there's the lever and counterweight method. Imagine lifting one side of the stone just enough to slide a block underneath it, then repeating the process in tiny increments. Over time, the stone could be raised onto a platform or moved onto sledges without ever requiring a single massive lift. This incremental lift method turns an impossible problem into a manageable, if extremely slow one. Of course, There's one other theory that keeps people arguing in late-night history forums: sound and resonance. Some fringe researchers propose that ancient builders might have used acoustic vibrations to reduce the weight of stones temporarily. The idea is that sound waves could cause the stone to slightly lift or float by disrupting the force of gravity. A concept so far unproven, but tantalizing enough to keep the mystery alive. In the end, perhaps the answer isn't one method, but a combination. Ancient engineers were masters of optimizing human labor, mixing physical strength, mechanical advantage, and a deep understanding of their environment. They might have used sledges over wet sand in Egypt, stone ball bearings in South America, and lever systems in the Middle East. The real engineering marvel here might not be the stones themselves. It's that the builders adapted their methods to the land, the materials, and the problem at hand, every single time. Chapter 6: The Lost Science of Leverage. When we hear the term leverage, most of us picture a simple seesaw or a crowbar. But to the ancient engineers who moved stones weighing more than 1,000 tons, leverage was not just a principle. It was an art form, refined over generations. In many archaeological sites, from the Baalbek trilithon stones in Lebanon to the unfinished obelisks in Egypt, there is evidence of large pivot stones, embedded fulcrums, and unusual wear patterns in the surrounding rock. These are not the random scratches of time. They're the signature of an advanced, highly calculated method of movement. Imagine a massive stone resting in a carved cradle of smaller stones and logs. A team of workers would insert thick wooden poles beneath it, then pivot it millimeter by millimeter using long beams as levers. Each movement would be secured with wedges, ensuring the stone didn't roll back or shift unexpectedly. Over time, this painstaking process could move even the heaviest monoliths across great distances. But here's the kicker. Ancient leverage wasn't just about wood and stone. Some researchers believe these civilizations understood counterweights in ways we can barely imagine. Imagine tying a huge stone to a system of ropes and pulleys connected to a cliffside. Workers on the higher ground could walk down a slope, letting gravity pull their weight, and with it, lifting or moving the giant block below. The Egyptians, for instance, were masters of counterweight systems, often using large baskets filled with sand. By slowly releasing sand from these baskets, they could control the exact movement of a load, like the slow, deliberate lowering of a 1,000-ton obelisk into place. Even more intriguing is the possibility that they used water as a counterweight. In certain sites, underground channels lead to stone platforms, suggesting that filling or draining these spaces could subtly shift massive loads. Think of it as an ancient hydraulic lift. No pistons, no steel, just the controlled flow of water. Modern engineers have tested some of these theories and found them surprisingly effective. A team in Japan, for example, managed to move a multi-ton block using nothing more than levers, rollers, and a counterweight system. The block moved so smoothly that it seemed almost effortless, proof that the principles of leverage, when applied with precision, can achieve miracles without modern cranes. But here's the real mystery. If ancient civilizations mastered leverage to this extent, Why don't we see written manuals or diagrams explaining their methods? Did they guard their techniques like trade secrets, passing them down orally from master to apprentice? Or were these methods considered so obvious to them that they never bothered to record them at all? The absence of records has led some researchers to speculate about something more controversial, that perhaps these techniques weren't entirely human inventions. Could the knowledge have been shared by a more advanced culture, long forgotten, or even by visitors from beyond? Whether you believe that theory or not, the undeniable truth is this. Ancient engineers had a relationship with physics that was as intuitive as it was brilliant. They didn't need heavy machinery. They had patience, precision, and a deep understanding of the natural laws of balance and force. And in the next chapter, we'll explore something even stranger. The possibility that some of these stones weren't moved at all in the traditional sense, but instead made lighter. A concept so radical, it challenges everything we know about construction. Chapter 7, The Leverage Trick. Picture this. A group of ancient builders standing in the shadow of a monolithic stone. One so large it would take a modern-day construction crane to even nudge it. They don't have steel cables. They don't have hydraulic lifts. But what they do have is an understanding of one of the most fundamental principles of physics: leverage. At first glance, a long wooden pole and a rounded stone don't seem like much of a match for a 1,000-ton block. But the ancient engineers knew that if you increased the length of the lever, you could multiply force dramatically. They understood, perhaps instinctively, that with the right pivot point and the right placement, a small group of men could move a stone that seemed impossible to shift. The principle is simple enough. A lever is essentially a rigid beam that pivots on a fulcrum. Place the fulcrum in the right position, and even a small amount of force on one end of the lever can produce an enormous effect on the other end. But applying this principle to stones the size of small houses was anything but simple. They would begin by slightly raising one side of the stone, perhaps using wedges and smaller levers. Then, they'd insert a large beam underneath and position it over a solid pivot. Anything from a pile of smaller rocks to a specially shaped wooden block. By pushing down on the far end of the beam, the other side of the lever would lift the massive stone, allowing them to slide supports or rollers underneath. Once the block was off the ground, even by a few centimeters, the game changed entirely. They could then combine the leverage trick with rolling logs or grease sledges to start moving it forward. Each short movement would be repeated hundreds of times, inching the stone along to its final destination. What's most fascinating is that this principle isn't just theoretical. It's been proven in modern experiments. Researchers and history enthusiasts have recreated ancient building techniques and found that with the right lever setup, a few people can move enormous blocks without machinery. In one case, a group of just 6 people managed to move a 20-ton block using nothing but wooden poles, pivot points, and sheer patience. Scale that up with more manpower and larger equipment, and suddenly, even a 1,000-ton stone becomes manageable. The ancients didn't stop at single levers either. They could arrange multiple levers in sequence, each one lifting the stone a little higher or pushing a little farther. It was like an ancient assembly line for movement, a step-by-step mechanical ballet. But here's where the mystery deepens. Some of the blocks, like those found in Baalbek, Lebanon, weigh well over 1,000 tons, more than any of our experimental reconstructions have ever attempted. The precision of their placement, sometimes within millimeters, raises questions. Did they use giant wooden cranes powered by human or animal tread wheels? Did they employ water or counterweights to boost lifting power? Or was there an even more advanced understanding of physics that we've yet to uncover? In many ways, the leverage trick was more than just a tool. It was a philosophy. Ancient engineers looked at a problem not with brute force in mind, but with creativity, calculation, and patience. They knew nature's laws could be bent to their will, even without the engines of industry. And so, with the rhythmic creak of wood and the murmured chants of laborers, stones that should have been immovable began their slow journey across landscapes. One lever push at a time, the impossible became possible. Next, in Chapter 8, we'll explore a technique that turns the ground itself into a tool, sliding monoliths as if they were made of ice. This is where the mystery takes a truly unexpected turn. Chapter 8, The Leverage Revolution, Moving Mountains with a Stick. Imagine standing before a 1,000-ton block of stone, so large it could crush anything in its path. Most people would see an immovable object, but to the minds of ancient engineers, it was a challenge, a puzzle begging to be solved. And their solution? Something so simple it borders on genius: the lever. A lever is nothing more than a rigid beam that pivots around a point, the fulcrum. The physics is straightforward. A long lever can amplify force, allowing a single person to lift or shift a weight far beyond their own strength. It's schoolbook science today, but to ancient builders, it was a game changer. Archaeologists have uncovered evidence of massive wooden beams used as levers in megalithic construction. These weren't the small crowbars you picture in modern hardware stores. These were tree-length poles, thick as a man's torso, set into grooves carved into stone. Workers would wedge these beams under the edges of a block, then throw their full weight, or even jump, onto the opposite end, shifting the stone inch by inch. And here's where it gets even more brilliant. The ancient crews combined levers with layers of small stones, logs, or clay platforms. Each time they lifted the block slightly, they'd slide supports underneath, gradually walking the stone upward or forward. It was painstaking work, but over time, the block would inch toward its final resting place. Some ancient illustrations, especially from later Roman engineering manuals, depict workers using multiple levers in unison. Imagine a dozen men, each working a massive pole in perfect rhythm, lifting one side of a megalith like a team of synchronized athletes. One heave, then another. The sound of creaking wood, the groan of stone against stone, the air thick with the smell of sweat and pine resin. But here's what's fascinating. Levers alone weren't enough for the truly massive blocks, like the 1,000-ton stone of the pregnant woman in Baalbek, Lebanon. The ancients had to pair levers with other tools in their arsenal: sledges, lubrication, and perhaps even early forms of mechanical gears. Modern reconstructions have proven this method works. Experimental archaeologists have moved multi-ton stones using levers and manpower alone. The process is slow, but incredibly effective. No cranes, no engines, just wood, muscle, and a deep understanding of physics. Think about it. The very same principle your child uses when playing on a seesaw could shift stones so massive that modern construction companies would struggle to handle them without heavy machinery. This mastery of leverage proves something vital. Ancient engineers didn't just work harder, they worked smarter. They didn't brute force nature. They negotiated with it, using balance, physics, and patience to achieve what we still marvel at thousands of years later. Chapter 9: Lessons from the Past. If there's one thing ancient engineers left us, it's not just the marvels they built. It's the lessons they encoded within their work. These lessons transcend stone, rope, and manpower. They speak to human adaptability, creativity, and our unending desire to solve problems, no matter how impossible they seem. The first lesson: leverage what you have, not what you wish you had. Ancient builders didn't sit around lamenting the absence of cranes or engines. They asked themselves, what can we do with what's here? Whether it was using the buoyancy of water, the stability of wooden sleds, or the power of organized manpower, they took stock of their available resources and maximized them to the fullest. The second lesson: work with nature, not against it. They understood the rhythm of the seasons, the direction of the wind, the softness of freshly watered sand, and the predictability of tides. Their projects often relied on aligning with these natural forces rather than resisting them. Where we might push and bulldoze, they adapted and flowed, turning nature into a partner rather than an obstacle. The third lesson: patience is as important as skill. In a world obsessed with speed, it's easy to forget that the ancient world built things meant to last thousands of years. A temple or stone monument wasn't completed in months. It could take decades, sometimes centuries. But the result? Structures that stand today as a testament to that patience. And perhaps the most powerful lesson of all: true progress isn't just about tools, it's about thinking differently. We tend to believe innovation comes from new gadgets, but more often it comes from new perspectives. Ancient engineers thought sideways, finding elegant solutions in simplicity. They reminded us that the human mind, when challenged, is the greatest machine of all. Today, with all our cranes, AI, and computational models, we might think we've surpassed them. But if we strip away our tech, could we do what they did? Could we move 1,000-ton stone with nothing but rope, wood, and muscle? Maybe the better question is, will we even try? These monuments stand not just as physical feats, but as whispers from the past, telling us that limits are only as real as we make them. And if we can remember that, perhaps the next time we face an impossible challenge, we'll stop saying we can't and start asking, how can we? The ancients already gave us the answer. We just need the courage to use it. Chapter 10: What we still don't know and why it matters. As we stand in the 21st century, surrounded by cranes that can lift hundreds of tons, satellites that map the Earth in minutes, and AI models that can simulate entire construction processes, it's easy to assume we've surpassed the ingenuity of the ancients. But the truth is more humbling. We still don't fully understand how they did it. The moving of 1,000-ton stones without modern cranes remains one of history's great engineering mysteries. Not because we lack ideas, but because we can't prove any single one with certainty. And each theory raises as many questions as it answers. Did they use ramps, sledges, and lubrication techniques that simply haven't survived in the archaeological record? Did they exploit principles of leverage and counterweight systems to their absolute maximum? Or, controversially, do they have access to knowledge, tools, or materials we don't recognize in our current historical framework? Here's what makes this fascinating. Every discovery we make about ancient engineering forces us to rewrite history. It challenges our assumptions about human capability, creativity, and the pace of technological progress. It reminds us that primitive is often a label we use when we don't understand something. And perhaps most importantly, it inspires. Because if ancient builders, without electricity, without engines, without modern technology, could design and execute projects that baffle our best engineers today, what limits are we setting on ourselves in the modern era? What breakthroughs are we dismissing simply because they don't fit our current way of thinking? So the next time you look at the Great Pyramids, the Trilithons of Baalbek, or the temple stones of Ollantaytambo, remember, you're not just looking at ancient ruins. You're looking at a challenge, a puzzle, a reminder that the story of human innovation is far from complete. The ancients didn't have tech. Or did they? Maybe, just maybe, they had something even more powerful. The relentless will to make the impossible possible.